composition. Aggregation. Aggregation is a specialized form of association where all objects have their own life cycle, but there is ownership. And child object cannot belong to another parent. Now, child and parent does not mean inheritance here. Child and parent does not mean inheritance here. You can see here, in this case, soldier has weapon. So, soldier is parent. And weapon is child. Okay. In case of hazard, this soldier has weapon. So, soldier is parent and weapon is child. So, once again, aggregation is a specialized form of association where all objects have their own life cycle, but there is ownership, and child object cannot belong to another parent object. The child object can belong to only one parent, cannot belong to another parent. Let's take an example of department and teacher. Single teacher cannot belong to multiple departments, but if we destroy department, teacher object will not destroy. So teacher has department. Department has teacher. Department has teacher and not vice versa. So here department is a parent and teacher is a child. Now that teacher works for a particular department, that teacher cannot work for any other department. That's the rule of aggregation. And the main concept here is, if parent is destroyed, child object stays there. That child object can work for different parent. If parent is destroyed, child object does not get destroyed. That child object stays there and can work for any other different parent. So department has teacher. If we close the department, teacher will not be destroyed. Teacher will be there. Teacher may go and work for some other department. That is aggregation. Whereas composition, specialized form of aggregation, we can call this as death relationship. And the main difference here is when parent dies, all the child objects also, they die. For example, house and room. Now you can't take here department and teacher example. Department and teacher example is an example of aggregation, where even if department is closed, teacher is not destroyed, teacher is still there. Teacher may go and work for some other department. But composition is a concept where when parent dies, child objects also, they die. So example, house and room. House has rooms. Room or rooms. So house is a parent and room is a child. What happens when house is destroyed? Obviously, rooms are also destroyed. Another example of composition. Your MCQ, poll question. Question has got multiple options. So question is a parent and option is a child. Now what if we destroy that question? If we destroy the question, obviously all options also will be destroyed. So that is another example of composition. Now aggregation and composition example can be given. They are very simple. The way I have given you one or two examples, you can have 5-6 examples like that, and you can explain in the interview. But what is challenging job here is to prove using some code that this code belongs to aggregation and this code belongs to composition. So using that code or through the code, through Java code, how will you prove that, see, parent has been destroyed, but child is still there. So this is the example of aggregation. Whereas parent is destroyed and child also is destroyed. This is the example of composition. So how will you write the code for aggregation and composition? That we have to discuss. And that is there in this folder. Day 4, aggregation demo in Java and composition demo in Java. First of all, we will see aggregation demo in which the same example is there. Department has teacher. If we close department, teacher is still there. Teacher can go and work for some other department. Composition demo in Java. Composition example in Java. There, same example is taken, house and rooms. If we destroy house, rooms also will be destroy. So first I will take aggregation demo in Java. It's not a Java file. Basically, I have to take this code and run it. Now using this code or through this code, we will prove that this is a code of aggregation. You will see that we'll have to draw diagrams also. So we'll do that. First of all, this is okay. Output we will see afterwards. First, let us understand this example. We need a canvas for drawing. Okay. Class teacher. It has got name and age. Parameter is constructor to accept name and age. Getters and setter methods. Getters and setter methods. And then teacher has got work method. Teacher is working. Class department has teacher. See, department has teacher. Department is one class, teacher is another class. So inside department, when we have teacher, we can say department has teacher. So first of all, this is has a relationship. But within has a, whether it is aggregation or demo, that we will get the answer at the end. Private string dname, that is department name. So department class has got two members, teacher reference and string dname. Parameter is constructor of department which takes only department name. Get department getter method. Getter method. There's no setter method for department name because you are supposed to set department name while creating object of that department. So it's okay. And then there's a add teacher method. Add teacher. Add teacher's argument is teacher. And then this dot teacher is equal to teacher. So in order to add teacher inside department, there's a add teacher method given. And then we have perform. Perform. Now department performs means who performs actually, who works, teacher works. So inside departments perform, we have rightly called teacher.work. So when department performs, that means teacher work. Okay, so this is class teacher and class department. Has a relationship is there. In the main function, there are some statements. We'll go one by one and draw the diagram. First of all, department SD is equal to new department, science department. So when you create object of science department, when you create object of department, how many members department has got? Two members, teacher and dname. Department SD is equal to science department. science department. Parameterized constructor will be called, and then department has got two members, teacher and dname. So this is dname and this is teacher. Teacher is a reference. Teacher. That teacher is null in the beginning. Then we have department MD is equal to new department maths department. So same story. One more object. This is maths department. Maths department. And once again for that department teacher is null. So department has been created, just teacher has not been added into that department. So teacher is null. Okay. Thereafter, SOP SD.getName science department, MD.getName maths department. Teacher T1 is equal to new teacher ABC 35. So T1. First of all, I forgot to write references SD and MD. So SD refers to this and MD refers to this maths department. Okay. Teacher T1 is equal to new teacher ABC 35. So now teacher has come. Teacher T1 is equal to new teacher. And when you create object of teacher, how many members teacher has got? Two members. They are name and age. So you are passing ABC and 35. So in the diagram, ABC and 35. ABC and 35. Okay. Thereafter, MD dot add teacher T1. MD dot add teacher T1. Now, just now I showed you add teacher method is there in the department, so that we can add teacher inside department. Now you are calling that add teacher, but who's the add teacher you are calling? MD. Maths department add teacher you are calling by passing T1. So add teacher has got teacher reference. This dot teacher is equal to teacher. That means this teacher ka address, this teacher's address will go in this reference, maths department. So it means this reference teacher refers to this. This reference refers to this object. MD dot add teacher. MD dot perform. Now when you say MD dot perform, control goes to perform. So teacher dot work. So this teacher will work. Then we have, let's close the maths department. Let's close the maths department. MD is equal to null. What will happen when you say MD is equal to null? MD is equal to null. So this relationship will go, this object will go,
Garbage.
this object will go, but will teacher object go? Maths department object will go. Will teacher object go?
No.
No.
T1 is
Because T1 is there. Yes. So department has been closed, but teacher is still there. Aggregation. T1 dot get name. Yes, teacher is there. Now SD dot add teacher T1. Since maths department has been closed, we would like to add the same teacher to science department. So what is going to happen in the diagram? This teacher will refer to this object. This teacher inside science department will refer to that teacher. Science department dot perform. So once again, who actually works? That teacher works. And after some time, let us close science department as well. SD is equal to null. SD is equal to null means this is null. And this object will be garbage collect. I mean marked for garbage collection. Now even if, once again, even if science department goes, will this teacher go? No, because T1 is there. So as long as T1 is there, T1 scope is there, this teacher object will stay in the memory. So even if parent dies, child does not die, child stays and can work for some other parent. This is aggregation. So you have to prove like this using your code. And the output can be seen here.
So can you show the code?
Which part you would like to see? Teacher.
Yes.
Teacher has got work also. Work. Department class. Okay, add teacher, teacher.work has a relationship. But that has a is what kind of aggregation? Because even if parent dies, child does not die. And finally, main function. These are the places where we are destroying that parent and we check whether child is there or not. MD is equal to null, SD is equal to null. Now, what trick has been implemented in this program so that teacher always stays no matter whether you delete department? Teacher's reference is created in the main function. So as long as T1 scope is there, teacher will not die. Teacher will not get destroyed as long as T1 is there. That trick we have done. And every time we give this T1 to each and every object of department, add teacher T1, add teacher T1. So even though that department object is destroyed, our teacher object does not get destroyed because teacher ka reference T1 is created in the main function. So as long as main function scope is there, T1 scope is there. So teacher will not be destroyed. So that trick has been implemented in order to prove that this is the example of aggregation. Now we'll see composition example. Composition example in Java. Composition.